Okay guys, good evening and welcome back to Electric Circuits. In this session, we shall talk about how to do the power calculations when the voltages and currents are sinusoidal. So when the voltage and currents are sinusoidal, how do you calculate the power supplied by any source or the power absorbed by any element and so on, okay? So what is it? Power calculations in AC circuits. AC circuits, it means what? Our circuits will be driven by sinusoidal or AC sources, in which case all voltage and currents at steady state, they are going to be sinusoidal. And in that case, what are the various values of powers absorbed and also powers dissipated, okay? So let's consider a very general case where we have a two-terminal element. This two-terminal element can be anything. Let's say the voltage across this element is what? Sinusoidal. Let it be equal to some Vm cos omega t plus theta. So what is the voltage drop across this two-terminal element? It is some Vm cos omega t plus theta. So what is Vm? It is the amplitude of the voltage across the element. Omega is what? The frequency is at which the voltage will oscillate and so on. And then theta is what? The phase angle of the voltage. Theta is what? The phase angle of the voltage. Vm is what? The amplitude of the voltage. At sinusoidal steady state, every current and every voltage is what? Sinusoidal. Even the current through this element, look at the current direction. This current, is it not entering the plus terminal? Yes. Let us call this current as what? I of t. Let's call this current as what? I of t. Even this current is going to be sinusoidal. Let it be of the form Im cos omega t plus phi. Again, what is Im here? It is the amplitude of the current through the element, and phi is what? The phase angle of the current. So Vm is what? The amplitude of voltage. Im is what? The amplitude of current. Theta is what? The phase angle of the voltage. Phi is what? Phi is what? The phase angle of the current. So from now onwards, we will always stick to this notation. Theta is always going to be angle of the voltage or the phase angle of the voltage, and phi is always going to be the phase angle of the current. So theta denotes what? The phase angle of the voltage, whereas phi will denote what? Will denote what? The phase angle of the current, okay? Let's be clear about this notation. Now, what is the power absorbed by this two-terminal element? What is the definition of power absorbed by any two-terminal element? Voltage times current flowing from plus to minus, whatever be the nature of the element, whether it's a passive element or some source, the power absorbed by any two-terminal element will always be equal to what? Voltage multiplied with the current flowing from plus to minus. What is the voltage here? V of t. What is the current flowing from plus to minus or current flowing into plus? Is it not I of t? So if you multiply V of t and I of t, you will get the power absorbed by this two-terminal element, okay? So P ABS is what? The power absorbed by this two-terminal element. Will it not be equal to V of t times I of t? Power absorbed by this element will be equal to what? V of t times I of t. So in place of V of t, you write this thing. In place of I of t, we must write this thing. Then you will get some expression for the power absorbed by this two-terminal element. We will go to the next slide and then get the expression for the power absorbed, okay? Look at this. So P ABS is what? V of t into I of t. So V of t is what? Vm cos omega t plus theta times I of t is what? Im cos omega t plus phi. Vm cos omega t plus theta times Im cos omega t plus phi. So first I'll just write the product of the two amplitudes, that is what? Vm times Im, then I'll write cos of omega t plus theta times cos of omega t plus phi. Cos of omega t plus theta times cos of omega t plus phi. Now this omega t plus theta, it is like A, and omega t plus phi, it is like B. So is it not like cos A into cos B? Cos A into cos B. You know, from basic trigonometric identities, we know cos A times cos B. Cos A times cos B. I think it can be written as what? Cos of A minus B plus cos of A plus B whole divided by 2. This is a basic trigonometric identity. Cos A cos B is equal to what? Cos of A minus B plus cos of A plus B divided by 2. Because cos of A minus B is what? Sorry. Cos of A minus B is what? Cos A cos B plus sin A sin B. And then cos of A plus B is what? So the same cos A cos B minus sin A sin B. That sin A sin B will get cancelled out. You will have 2 cos A cos B divided by 2, which is equal to what? Cos A cos B. That's all. And for us, this thing is what? A. This thing is what? B. Now let us go back to our expression for the power absorbed. Okay. So when you apply this identity, first term is what? Cos of A minus B. What is A minus B? Omega t plus theta minus of this. So when you subtract this from this, omega t will get cancelled. Won't you get theta minus phi? You will get what? Theta minus phi. Remember, you also have this 2 in the denominator. I think it will be Vm Im by 2 times cos of theta minus phi. This is what? The first term. What about the second term? Second term is what? Cos of A plus B. So when you add A and B, won't you get 2 omega t plus theta plus phi? And then you also have Vm Im and then this 2 factor. So the second term is going to be Vm Im by 2 times cos of 2 omega t plus theta plus phi. That's all. This is the final expression for the power absorbed by the two-terminal element. Vm Im by 2 times cos of theta minus phi plus Vm Im by 2 times cos of 2 omega t plus theta plus phi. See, so the expression for the power absorbed, clearly it contains what? 2 terms. There is what? The first term, there is what? The second term. Look at the first term. Is it not a constant? Please look at the first term in the expression for the power absorbed. Is it not a constant? Because the first term does not contain small t. It is what? Independent of time. It is going to remain constant. Vm Im by 2. Vm amplitude, Im amplitude. Amplitude of any sinusoidal quantity at steady state is going to be constant. So Vm Im 2, everything is what? Constant. Theta is what? The phase angle of the voltage, constant. Phi is what? The phase angle of the current, another constant. So theta minus phi is also what? Constant. Cos of theta minus phi is also what? Constant. So the point is what? This term, which one? This term, it is what? A constant. Whereas the second term, look at the second term, is it not a pure, pure sine function or cosine function? Vm Im by 2, it's like the amplitude, cos of some 2 omega t plus theta plus phi. So what is the, the power absorbed, is it not a periodic function? Yes or no? Power absorbed is also what? Periodic. Voltage and current are already periodic with a frequency of omega. Yes or no? Voltage and current both are periodic with a frequency of omega. Voltage period is, frequency is what? Omega. Current frequency is also what? Omega. Can you tell me what is the frequency of the power absorbed? Is it omega? 2 omega. Clearly, it is what? 2 omega. So the power absorbed by this two-terminal element is also a periodic function, but with a frequency of 2 omega. So whereas the voltage and current have a frequency of omega, the power function is also periodic and it will oscillate at twice the frequency. Frequency double, it means what? Time period will become half. You understood? So voltage and current both have a frequency of omega, whereas the power absorbed will have a frequency of 2 omega. Yes? And this is what? A pure sinusoidal function. When I say pure sinusoidal function, what it means is the average value of second term. What is the average value of the second term? Any pure sine wave, whether it is pure sine wave or pure cosine function, the average value is going to be 0. Yes? Now if I ask you, what is the average power absorbed by this two-terminal element? Average power absorbed by the two-terminal element will be equal to what? Average value of the first term plus the average value of second term. Yes, on average value of power absorbed will be equal to what? Average value of first term plus the average value of second term. Already I said second term is what? A pure sine function or a pure cosine function, whatever it is. For a pure sinusoidal function, the average value is going to be what? 0. So for the second term, the average value is what? 0. Whereas the first term is what? Independent of time, it is what? Constant. Constant itself means what? It is DC. So what is the expression for the average power absorbed by the two-terminal element? It is just this Vm Im by 2 times cos of theta minus phi. So this is what is called the average power absorbed by the element. This is a very, very important result. Okay, Vm Im by 2 times cos of theta minus phi. You understood? Yes. Just note it, all of you. Vm is what? The amplitude of the voltage. Im is what? The amplitude of the current. Vm Im by 2 times cosine or the cos of the phase difference between the voltage and the current. Phase difference between voltage and current. Okay. So P average, that is the average power absorbed by the two-terminal element, is what? Vm Im by 2 times cos of theta minus phi. Vm Im by 2 times cos of theta minus phi. You see, let's say we have a resistor. Let's say we have a resistor across which a sinusoidal voltage is applied. Okay, let the resistor have a resistance of R. Okay, and let the sinusoidal voltage applied be some Vm cos omega t. Vm cos omega t. Now, when you apply the sinusoidal voltage across the resistor, what is the current flowing through the resistor? Will it not be Vm by R cos of omega t? I mean, Ohm's law, voltage divided by resistance will give you what? The current drawn by the resistor. So voltage divided by R. So Vm by R cos omega t. So here, what is the angle of the, in fact, for a resistor, always voltage and current are going to be in phase. Voltage and current in phase, it means what? Theta minus 5, is it not 0 degrees? And cos of theta minus phi, will it not be 1? Yes or no? In this expression for power absorbed, we have what? Cos of theta minus phi. Theta minus phi is what? The phase difference between the voltage and the current. For a resistor, everybody knows that voltage and current will always be in phase. That means what? The phase difference is 0. Theta minus phi is what? 0 degrees. So cos of theta minus phi is what? Cos 0, which is 1. Okay. Now what is the average power absorbed by this resistor? Let us just use this formula. What is this formula? Amplitude of voltage. Amplitude of voltage is what? Vm times amplitude of current. What is the amplitude of current? Is it not Vm by R? Vm by R divided by 2 times cos of theta minus phi, which is already equal to what? 1. So into 1. So is it not Vm squared by 2R? I mean, there is something you already know, yes. So if you apply a sinusoidal voltage across a resistor, then the average power dissipated by the resistor is equal to what? Vm squared divided by 2R, or Vp squared by 2R. Now, across the same resistor, let us connect a DC voltage source. Let us connect a DC voltage source. So if you connect a DC voltage source across the same resistor, now what is the average power dissipated by the resistor? In fact, DC voltage applied across R, the current is also going to be DC. Voltage DC, current is also what? DC. Even the power absorbed by the resistor, will it not be constant? It will be what? Independent of time. So the instantaneous power will be same as what? The average power. By the way, whatever power absorbed expression that we got earlier, first term plus second term, because the second term is what? Function of time. This power absorbed, it is what? The instantaneous power absorbed by the element. So this whole expression, it represents what? The instantaneous power absorbed by the element. Why instantaneous power? Instantaneous power. Spelling. Instantaneous. Instantaneous power absorbed by the element. Because first of all, this instantaneous power absorbed by the element, it is what? A function of time. So in place of small t, if you put 1 second, then you will get what is the exact value of the power absorbed at 1 second. In place of small t, if you put 5 seconds, or if you put 10 seconds, you will get the exact value of the power absorbed by the element at 10 seconds. So are you not able to find the power absorbed at any specific or a particular instant by using this expression? That is why this expression is called as what? Instantaneous power absorbed by the element. Now coming back to this case, where we have a DC voltage source connected across a resistor. Because the DC voltage source itself means what? Voltage is constant. Even the current will be what? Constant. Voltage constant, current constant. Voltage into current is also what? Going to be constant. So power absorbed by the resistor will always be constant. So there is nothing like a separate instantaneous power and an average power. Both are identical. Yes. So in this case, what is the average power dissipated by the resistor? Is it not V DC square divided by R? Yes. And whenever a resistor dissipates power, won't there be some heating? Yes or no? Whenever resistor dissipates power. When will resistor dissipate power? Whenever current flows through what? Resistor. Yes. Whenever current flows through resistor, resistor will dissipate some energy or power. And that will be dissipated in the form of what? Heat. And because the energy is what? Dissipated in the form of heat, after some time the resistor, it will become what? Hot. Resistor will become hot. So there is some heating of the resistor. There is some heating for the resistor. Now the question is, what should the value of the DC voltage source be such that in both the cases the resistor will have the same heating effect? What is the value of the DC voltage that should be applied across the resistor such that the resistor will have the same amount of heating effect in both the cases? For the resistor to have the same heating effect, in both the cases the average power dissipated by the resistor must be same. That means this VDC square by R must be equal to what? This Vm square by 2R. Yes, Vm squared by 2R. So clearly R and R will get cancelled. When R and R get cancelled, VDC, will it not be equal to Vm by root 2? VDC will be equal to what? Vm by root 2. So what is the thing here? First, we apply a sinusoidal voltage across this resistor, and the amplitude of the sinusoidal voltage is some Vm. And because of this sinusoidal voltage applied across the resistor, there will be some heating effect for the resistor. Okay. And then across the same resistor, now we will connect a DC voltage source. But in both the cases, we want the resistor to get heated to the same extent. In both the cases, we want the resistor to get heated to the same extent. In that case, what should the value of the DC voltage that must be applied so as to produce the same heating effect for the resistor in both the cases? The value of the DC voltage that should be applied across the same resistor is equal to what? Vm by root 2, where Vm is what? The amplitude of the sinusoidal voltage that is initially applied across the resistor. In fact, this equivalent DC voltage that should be applied across the resistor to produce the same heating effect is what is called the RMS value. You understood? This is the physical significance of RMS value. So this DC voltage that should be applied across the resistor, which will result in the same heating effect, is what is called the RMS value of the original AC voltage that is applied across the resistor. So the original sinusoidal voltage is what? Vm cos omega t with an amplitude of Vm, and its RMS value is what? Vm by root 2. So even though everybody knows that the RMS value of this is what? Amplitude divided by root 2, but this is how you get it. Okay, in case you don't know, there is something new. Okay, so this Vm by root 2, this Vm by root 2 is what is going to be the RMS value of the sinusoidal voltage. RMS value of the sinusoidal voltage. You understood? Yes. So just to conclude, so if you have a sinusoidal voltage, something like Vm cos omega t plus theta, then what is its RMS value? It is Vm by root 2. And similarly, if you have a sinusoidal current, something like Im cos omega t plus phi, even this, in fact, any periodic function will have an RMS value. You can find the RMS value of any periodic function. Even Im cos omega t plus phi will have an RMS value of what? Amplitude divided by root 2. So this amplitude divided by root 2 is applicable for any sinusoidal function. Okay. So RMS value, will it not be Im by root 2? Yes. Now in the context of power calculations in AC circuits, this RMS value is also called as effective value. RMS value is also called as what? Effective value. Okay. So RMS, let me just write it. So going forward, when I say effective value of voltage, you should not be confused. Effective value of any voltage is what? RMS value of that voltage. Effective value of any current is what? RMS value of that sinusoidal current. Okay, so RMS value is also same as what? Effective value. Yes. So this Vm by root 2, I can call it V effective. Im by root 2, I can call it I effective, because effective value is nothing but the RMS value. You understood? So V effective is what? The RMS value of this voltage, which is equal to what? Vm by root 2. And I effective is what? The RMS value of this sinusoidal current, which again is equal to what? Im by root 2. I hope the notion of RMS or the effective value is clear. Yes. Now you can find the RMS value of any periodic function, right? So RMS means what? Root mean square. So let's say we have a function x of t which is periodic, which is periodic with a time period t. Okay, so we have a periodic function or periodic signal x of t whose time period is what? Some capital T. X of t is periodic with a time period capital T. Okay, then the RMS value of this periodic signal, root mean square. That means what? You have to square the signal, and then you have to compute the mean of the square, and then you should take the square root of the whole thing. Then you will get the RMS, that is what? The root mean square value of this periodic signal x of t. So first you have to square the signal. Then you have to compute the mean square value of this signal. Okay. To compute the mean square, you should integrate the square of the signal over one time period or over one cycle. Look at this. We are integrating x square of t with respect to time from 0 to t. So this will, this is not mean square. When you divide this by the time period, that is what? Capital T, then you will get mean square. Okay. So 1 by t times integration of x square t dt from 0 to t will give you what? Mean square. RMS means what? Square root of this whole thing. So this is what? Root mean square. Okay. Let me write it properly. So this is root mean square value. Okay. And for a sine function, the RMS value is what? The amplitude or the peak value divided by root 2. Yes. So I'll just draw a couple of commonly encountered waveforms, and for every periodic waveform I'll just write the corresponding RMS value. Okay. So the first waveform is what? Sinusoidal with a amplitude of Vm, which varies between Vm and minus Vm. And the second waveform this is what? The second waveform. Let me draw one more waveform. This is what? The third waveform. This is the fourth waveform. So these are 5 different periodic waveforms. Okay, first is what? A pure sine wave, which varies between Vm and minus Vm. What is the second waveform? Is it not the half wave rectified? The second waveform, that is what? This one, is it not the half wave rectified version of this pure sine wave? Yes. What is this waveform? Is it not the full wave rectified version of this pure sine wave? Yes. This of course is what? A triangular waveform, which again varies between what? Vm and minus Vm. This is what? A sawtooth waveform, also varying between Vm and minus Vm. So for all the waveforms, the amplitude is what? The same, Vm. For all the waveforms, the amplitude is what? The same and equal to what? Vm. And all are also periodic signals. All are periodic signals. I told you what? For every periodic signal, we can compute the effective or the RMS value. And this is the way to calculate the RMS value of any periodic signal. Square the signal, integrate the square of the signal over one time period divided by the time period, take square root, you will get the effective or the RMS value. Yes. Now what I will do, I will just write the RMS values of each of the 5 different waveforms here, okay. First is what? Pure sine wave. Pure sine wave RMS value, already we know it is what? Vm by root 2. And the second is what? The half wave rectified version of the pure sine wave. Its RMS value is going to be Vm by 2. And this waveform, as I said, is what? The full wave rectified version of this pure sine wave. Its RMS value is also same as what? The RMS value of the original pure sine wave, which is Vm by root 2. This one is what? Triangular waveform, which varies between Vm and minus Vm. Its RMS value is what? Vm by root 3. This is what? A sawtooth waveform, which also varies between minus Vm and plus Vm. Its average value, not average, sorry, RMS value is also going to be Vm by root 3. So these are the RMS values of some of the commonly encountered periodic signals or periodic waveforms, okay. So pure sine wave, half wave rectified version of pure sine wave, full wave rectified version of pure sine wave, triangular waveform, and the sawtooth waveform, okay. Now what is that result that we got previously for the power absorbed or the average power absorbed by any element? So first of all, if you have a two-terminal element across which the voltage drop, the phasor voltage drop, it is some V effective angle theta, through which the phasor current is what? I effective angle phi, okay. So this time for the two-terminal element, the voltage and current are represented in the phasor domain. The phasor voltage is what? V effective. V effective meaning what? The RMS value followed by the phase angle, which is what? Theta. And the current flowing from plus to minus is what? I effective angle phi, yes. And previously the result that we got for the average power absorbed by the element, what is the average power absorbed by the element? Is it not Vm Im by 2 times cos of theta minus phi? Can it not be written as Vm by root 2 times Im by root 2 times cos of theta minus phi? Now for a sinusoidal voltage or for any sinusoidal function, the RMS value or the effective value, is it not the amplitude divided by root 2? So Vm by root 2, is it not same as V effective? Similarly, Im by root 2, is it not same as I effective? So Vm by root 2 can be written as what? V effective. Im by root 2 can be written as what? I effective, and then cos of theta minus phi. That's all. This is the expression for the average power absorbed by any two-terminal element or a two-terminal network. Average power absorbed by any two-terminal element or two-terminal network is given by V effective. V effective is what? RMS value or the effective value of voltage across the two-terminal element. I effective is what? The RMS value or the effective value of the current flowing through that two-terminal element. RMS value of voltage into RMS value of current into the cosine of the phase difference between the voltage and the current. Remember, theta is what? Angle of voltage. Phi is what? The angle of the current. Cos of theta minus phi, okay. Now what are the three basic passive elements that we have? First is what? Resistor. So resistor is something we have already seen. For a resistor, voltage and current will be in phase. So the phase difference between voltage and current is what? 0 degrees. So cos of theta minus phi is also what? 0. Cos of theta minus phi is 1, I'm sorry. Cos 0 is what? 1. So what is the average power dissipated by a resistor? So is it not simply V effective into I effective? In general, it is what? V effective into I effective times cos of theta minus phi, because cos theta minus phi is what? 1. The average power absorbed by a resistor is what? The product of the RMS voltage and the RMS current, okay. So it is from this that we can get the other two expressions as what? V effective squared divided by R, or I effective squared into R. yes, square of the RMS voltage divided by resistance, or square of the RMS current multiplied with resistance, V effective squared divided by R, or I effective squared into R, okay. And then we have the two reactive elements in the form of what? Capacitor and inductor. Yes, for a capacitor, you know, current leads voltage by 90 degrees, yes. So angle of I minus angle of V is what? 90 degrees. Angle of I, phase angle of current, is what? Denoted by phi. Angle of V, phase angle of voltage, in our notation or in our convention, is denoted by theta. So what is phi minus theta? It is 90 degrees. So what is theta minus phi? Is it not minus 90 degrees? So what is cos of theta minus phi? Is it not cos of minus 90 degrees? Cos plus 90 or cos minus 90, both are 0. So cos of minus 90 degrees is what? 0. Yes. So what is the average power absorbed by the capacitor? That is also going to be 0. Average power absorbed by a capacitor is what? 0. Okay. Because theta minus phi is what? Minus 90 degrees, and cos of theta minus phi is going to be 0. So the average power absorbed by a capacitor is what? 0. Okay. In fact, for a capacitor, okay, for a capacitor, what is the expression for the instantaneous power absorbed by the capacitor? Let us go back to the expression for the instantaneous power absorbed by any two-terminal element. Instantaneous power absorbed by any two-terminal element, if you recall, we got it as what? Vm Im by 2 times cos of theta minus phi plus Vm Im by 2 times cos of, if you recall, we found that the power absorbed is also periodic, but the frequency will be twice that of the sinusoidal voltage or the sinusoidal current for that element. Okay, voltage and current will have a frequency of omega, whereas the power function is what? Periodic, with a frequency which is 2 times omega. Okay, that is what? 2 omega. So cos of 2 omega t, yes or no? Cos of 2 omega t plus theta plus phi. Now for a capacitor, you know, this theta minus phi is going to be minus 90 degrees. So cos minus 90 degrees is what? 0. So this entire term, it will become what? 0. So what is the expression for the power absorbed? So is it not Vm Im by 2? If you want, you can write this Vm Im by 2 as what? V effective into I effective, because Vm by root 2 is what? V effective. Im by root 2 is what? I effective, times cos of 2 omega t plus theta plus phi. So if you try to plot, so is it not a sinusoidal function? Power absorbed by capacitor, it is what? A pure sinusoidal function. Pure sinusoidal function, it means what? You won't have any extra DC term. You won't have any extra DC term plus some DC value that won't exist. Then it is what? Pure sine function, pure sine function. Okay, any pure sine function, it will simply sinusoidally oscillate between plus Vp and minus Vp. You understood? So for this sinusoidal function, the amplitude, it is like V effective into I effective. Okay, so what we will do now, we'll just try to plot the power absorbed versus time. So P AVS versus time. Then we will understand what exactly happens in a capacitor when the voltage applied across it is what? Sinusoidal. Okay. So V effective into I effective times cos of 2 omega t plus theta plus phi. So it is a pure sinusoidal function. So will it not be like this? It will be what? Like this. Okay. So the point is what? If you look at the waveform over the first half cycle, power absorbed, is it not positive? Yes or no? Power absorbed is what? Positive. Power absorbed, positive. That means what? Capacitor is getting charged. Yes or no? Power absorbed is what? Positive. Capacitor is what? Drawing power, or it is getting charged. Okay. So in the first half cycle, power absorbed is what? Positive. That means capacitor is what? Absorbing power. Whereas the same capacitor in the second half cycle, that is what? The negative half cycle, the power absorbed, is it not negative? Here power absorbed is what? Positive. Capacitor will absorb power and cap will get charged. But in the second half cycle, the power absorbed is what? Negative. Power absorbed negative, it means what? Power supplied by the capacitor, will it not be positive? When will the capacitor supply power? When it is getting charged or discharged? Capacitor will supply energy or power when it is getting discharged. So during one half cycle, the capacitor will absorb power and it kind of gets charged. And during the other half cycle, the same cap will get discharged and it will supply power. So if you look at the power absorbed waveform over one cycle, over one full cycle, you will find that for one half cycle, that is for half the time period, the cap will absorb power. For the remaining half, the cap will deliver power. So on the whole, what is the net power absorbed or net power delivered? Net power absorbed is what? 0. Net power delivered is also what? 0. Because the net power delivered is what? 0, the capacitor, even though it is able to supply power at least for some duration, still the capacitor is not called as an active element. In general, active means what? Any element that can deliver or supply power. So here, during negative half cycle, of this waveform, power absorbed is what? Negative, which means the cap is what? Actually supplying power. But still we call the capacitor as what? A passive element. So what is an active element? Active element is that element which can deliver an average power which is greater than 0. Which can deliver an average power which is greater than 0. Here, the average power delivered by the cap is what? 0. Instantaneous power delivered by the cap in the negative half cycle, it is what? Positive. But the average power computed over the entire full cycle is going to be 0. That is why the cap is what? Considered to be a passive element. You understood, right? So already the earlier result that we got is what? P average. Average power absorbed by capacitor is what? 0. It is only average power absorbed by the cap, that is what? 0. It does not mean cap will not absorb power. It also does not mean cap will not deliver power. Only the average power absorbed is what? 0. Similarly, the average power delivered by capacitor is also what? 0. Average power absorbed by cap is what? 0. Average power delivered by the cap is also what? 0. So as you can see from this waveform, for one half cycle, the cap will absorb power. For the other half cycle, the cap will deliver the same amount of power. So on the whole, no net power is what? Absorbed or delivered. That means the average power absorbed and also the average power delivered, both are 0. You understood? Yes. So reactive elements, that is what? The capacitor and the inductor will always get charged and discharged. During charging phase, they will absorb power. During discharging phase, they will deliver whatever power is already absorbed. You understood? Yes. And lastly, we have the inductor. So inductor, what is the property? Voltage leads current by 90 degrees. Yes or no? Always in an inductor, voltage leads current by 90 degrees, which means angle of V minus angle of I is equal to what? 90 degrees. Phase angle of voltage is what? Denoted by theta. Phase angle of current is what? Denoted by phi. Theta minus phi is what? 90 degrees. So once again, what is the cosine of theta minus phi? Will it not be 0? So if the cos of theta minus phi is what? 0. Even the average power absorbed by the inductor is also going to be 0. So both the reactive elements, the average power absorbed is what? 0. Both the reactive elements. Which two reactive elements? Capacitor and inductor. The average power absorbed is what? 0. That is why we say reactive elements do not dissipate power. Average power absorbed 0. That is why we say they do not dissipate any energy. Whatever energy will be absorbed, that will be stored, and during the other portion of the half cycle or the full cycle, the same energy that is already stored will be supplied back to the external circuit. You understood? So reactive elements do not dissipate energy or power. Okay. Look at this. Let's say we have a two-terminal element. We have a two-terminal element whose impedance is what? R plus Jx. We have a two-terminal element whose impedance is what? R plus Jx. Let's say the current in this element, the phasor current, let it be some I effective at an angle phi. I effective angle phi. That is the phasor current flowing through this two-terminal element whose impedance is what? R plus Jx. Please type in the chart box what is the RMS value, not RMS value. What is the average power absorbed by this element? Okay. What is the average power absorbed by the element? What is the average power absorbed by this element? Is it not I effective squared into R? Average power absorbed by this two-terminal element will be equal to what? I effective squared into R. Yes or no? Very good. I effective squared into R. So this branch, this R plus Jx can be represented as what? A series combination of a resistor and a reactive element whose impedance is what? Jx. R plus Jx can be split into the resistive part and the reactive part. For the resistive part, resistance is what? R, and for the reactive part, the impedance is what? J into X. Now also the same current will flow, which is equal to what? Some I effective angle phi. Now the power, average power absorbed by this two-terminal element will be equal to what? Average power absorbed by R plus the average power absorbed by the reactive element whose impedance is what? Jx. You know, any reactive element, the average power absorbed is what? 0. Yes. So for this, the average power absorbed is what? 0. Whereas for the resistor, the average power absorbed is always equal to what? Square of the RMS value of the current times resistance. What is the RMS value of the current flowing in this branch? RMS value is same as what? Effective value. I effective squared into R. So for the resistive part of the impedance, the average power absorbed is what? I effective squared into R. But for the reactive part of the impedance, always the average power absorbed or supplied, both are going to be 0. So what is the total average power absorbed by this element? I effective squared into R plus 0. Yes, that's all. So P average is what? I effective squared times the resistance. Okay, it is always the resistive part of the impedance that will contribute to average power absorption. It is always the resistive part of the impedance that will contribute to what? Average power absorption. But the reactive part of the impedance will not contribute to average power absorption. Okay, so what will happen with regard to the reactive element? Reactive element, for some time it will absorb power, for some other time it will deliver power. If the reactive element is what? Absorbing power, that means power is going from, or energy is going from source to the element. And for the other part of the cycle, the same reactive element will deliver power. In that case, what happens is energy will be transferred from the reactive element back to the source. So reactive element will draw energy from the source and it will give back that same energy back to the source. Whereas the resistive part of the impedance will always draw energy from the source. Whatever be the half cycle, whether it is what? Positive half cycle or negative half cycle, resistor will always absorb energy from the source. Okay. So the point is what? It's only the resistive part of the impedance that will contribute to what? Average power absorption. Okay. Please type your answer in the chat box. So here we have a very simple network which has an impedance Z whose value is what? 4 plus 3j ohms. connected across a sinusoidal voltage source whose phasor voltage value is what? 10 at an angle 30 degrees volts RMS. So what is this 10 volts? What is this 10 volts? It is the RMS value of the voltage. Yes, the question is what? To find the average power dissipated or absorbed by the impedance Z. Please type your answer in the chat box. So the average power absorbed by this impedance is not 25 watts. Because see, the impedance is not just the resistance alone. Impedance is not just the resistance alone. It is what? 4 plus 3j. It is what? 4 plus 3j. That means whatever voltage we have 10 at an angle 30 degrees volts RMS, it is what? It is what? The net voltage across this series combination 4 plus 3j. 3j, I mean the reactance is what? Positive. Positive reactance, it means what? It should be an inductor. So we have a resistor whose resistance is what? 4 ohms. We also have an inductor whose impedance is what? J3 ohms. Let me write it properly. Whose impedance is what? J3 ohms. Yes or no? So this entire thing is what? Z. Now obviously the power dissipated by Z will be equal to what? Power dissipated by the 4 ohm part plus the power dissipated by the J3 impedance. Okay, you have to find what? Average power. What is the average power dissipated by the inductor? The inductor is what? Purely reactive. Average power is what? 0. So the only element that will contribute to average power absorption is what? This 4 ohm resistance. Okay, but the thing is what? This voltage 10 at an angle 30 degrees volts RMS will not entirely appear across resistor. This voltage will actually get divided between the resistor and the inductor. If 10 volts is what? Entirely appearing across the resistor, then the average power dissipated by the resistor will be equal to what? Square of the RMS voltage, which is 10 into 10, 100 divided by the resistance 4, 100 by 4. As you all said, it would be 25. Did you all understand what your mistake is? I hope it is clear. Yes, this voltage will not entirely appear across resistor. Only a part of it will appear across the resistor. So you cannot say that the average power dissipated by the resistor is equal to what? 25 watts. You understood? So always you try to find the current. Whenever you have an impedance, always try to find the current. Once you find the current flowing through the impedance, same current will flow through what? R as well as the reactive part. Yes or no? If you go back to previous case, the current is what given for the impedance. You can see the same current flows through what? R as well as the reactive component. Because the same current flows through what? Both R and Jx, you can simply multiply I effective squared and the resistance to get the average power dissipated by the impedance itself. Okay. So here also let us try to find the current. Let's say the current drawn by the impedance Z be some capital I. Okay. So what is capital I? Capital I will be equal to what? The applied voltage, which is 10 at an angle 30 degrees volts RMS divided by the impedance. What is the impedance value? 4 plus 3j ohms. Again, what is 4 plus 3j in polar form? 4 plus 3j in polar form is what? 5 at an angle tan inverse 3 by 4. Look at this. 10 at an angle 30 degrees. By the way, what are the units of the current going to be? Volts by ohms. Volts by ohms is what? Amps. Because the voltage is in RMS terms, even the resulting current would be in RMS terms. Okay. So directly I'll write amps RMS. Amps RMS. So 10 angle 30 degrees divided by what is 4 plus 3j in polar form? 5 at an angle tan inverse 3 by 4. I think tan inverse 3 by 4 is what? Approximately 37 degrees. So what is 10 by 5? 2. I mean, forget about angle. We only require the effective value of the current, square it, multiply it with resistance, you will get the average power absorbed by the resistor. Okay. So is it not going to be 2 at an angle minus 7 degrees amps RMS? That's all. So what is the effective value of the current? So this 2 amps is what I effective. 2 amps is what I effective. That's all. Now we can write the average power absorbed by the impedance is same as what the average power absorbed by the 4 ohm resistor, because the inductor will not contribute to any kind of average power absorption or dissipation. Okay. So P average, is it not simply equal to I effective squared into, or I effective is what, 2. So 2 square into R is what, 4. 4 into 4, it is what, 16. So the correct answer is what, 16 watts. Did you all get 16? Very good. So there is one simple aspect where many people commit a mistake. I hope now the point is clear. Okay. So we have this current I of t, which consists of 4 different components. Okay. So what is I of t? It is a sum of 4 different current components. The first current is what, 3. What is this 3? Is it not DC? So the first current component is what, DC. What is the second term? 4 sine 40 plus 20 degrees. So it is what, sinusoidal, which has a frequency of 4 radians per second. What is the third term? 5 cos 10t minus 20 degrees. That is also what, sinusoidal, at a frequency of 10 radians per second. Last term is also what, sinusoidal, at a frequency of 20 radians per second. So are we not having all the 4 current components at 4 different frequencies? First is what, DC. Second is what, omega equal to 4. Third is what, omega equal to 10. Fourth is what, omega equal to 20. Any 2 sinusoidal functions at 2 different frequencies are always going to be orthogonal. Any 2 sinusoidal functions at 2 different frequencies are going to be orthogonal. So here all the 4 sinusoidal components are at 4 different frequencies. So all the 4 are mutually orthogonal with respect to each other. Okay. In such a case, how do you find the RMS value? Can't you find the RMS value of each and every component? Yes. For the first component 3 RMS is what, 3 itself. DC is same as what, RMS. Okay. That is only for DC. That is only for DC. So if you have a DC quantity, then its RMS value is also same as what, the value of the DC quantity. Okay. For the second term, what is the RMS value? 4 is what, amplitude divided by root 2, 4 by root 2. For the third term, what is the amplitude? 5. RMS would be what, 5 divided by root 2. For the fourth term, the RMS value would be what, 10 by root 2. So in this way, we can easily write down the RMS value of each and every component. Because all 4 components are going to be orthogonal, the overall RMS value is simply equal to what? The square root of the sum of the squares of the RMS values of all the individual current components. Okay, so here I effective will be equal to what? Square root of 3 square plus 4 by root 2 square plus 5 by root 2 squared plus 10 by root 2 squared. You understood? Is that clear? Yes. I mean, why is the RMS value important? Let's say we have a resistor. Let's say we have a resistor R through which the original current I of t is what, flowing. We have a resistor R through which I of t is what, flowing. Now, if somebody will ask you what is the average power dissipated by the resistor, you have to find the RMS value of the current through the resistor, square it, multiply it with resistance. So P average will be equal to what? I effective squared into R. So how do you get this I effective value? From this expression. You understood? That is why the effective or the RMS value is what? Extremely important. we'll always use the RMS value when it comes to doing power calculations. Okay, is it clear? Yes. I think the first one is very straightforward. There is only one current component, which is 8 sine 200t. Amplitude is what? 8. RMS value is going to be amplitude divided by root 2. Yes. So for the first one, directly we can write V effective, that is what the RMS value of voltage is going to be 8 by root 2. 8 by root 2 volts. Okay. I mean, you can get the value, but I'll just leave it as 8 by root 2 volts. If you look at the second voltage, it consists of what? Two sinusoidal components, or two sinusoidal current, voltage components. One is what? 8 sine 200t. The other voltage component is also at same frequency. So both components are at same frequency. In such a case, they are not going to be orthogonal. And if they are not orthogonal, you cannot simply take each individual RMS value, square it, and then add the two squares and then take square root. That cannot be done. That can be done only if the different components are at different frequencies. But here, the first component and the second component both are at same frequency. In such a case, you should combine these two into a single component. You should combine all the various components at one frequency into one single component. You understood? Yes. So I'll just do it in a different slide. So there is what? The B part. Okay. So you have to do something and combine the two components into what? One single component. Then you can easily write the RMS value. RMS value would be what? Amplitude divided by root 2. I think the the convenient way to combine the two components into one single component is by doing the analysis in the phasor domain. Okay. See, usually we take cosine as reference, but we can also take sine as reference. Okay. So if you take sine as reference, if you take the sine function as a reference, is it not going to be 8 angle 0 degrees? Yes. And if you take again sine as reference, for the second component, the phasor representation, would it not be 6 at an angle minus 45 degrees, 8 angle 0 degrees for the first component, 6 angle minus 45 degrees for the second component. Now the small vs in the phasor domain will become what? Capital Vs. 8 angle 0 degrees minus 6 angle minus 45 degrees. Okay. That's all. 8 angle 0 degrees is what? Just 8. And then minus 6 cos minus 45 degrees. And then minus j6. I'm just expanding the second phasor into rectangular format. Okay. Because it is in polar, I'll just convert it into rectangle so that we can add the two real parts and also the two imaginary parts and so on. Okay. So minus 6 cos minus 45 degrees minus j6 sine minus 45 degrees. Okay. Cos minus 45 degrees is same as what? Cos plus 45 degrees. So it will be same as what? 8 minus 6 cos 45 degrees. So this is like the real part. And then sine minus 45 degrees. Sine minus 45 degrees, is it not same as minus sine 45 degrees? Yes. Minus and minus will become what? Plus. So plus j times 6 sine 45 degrees. Okay. That's all. This is what? The real part. This is what? The imaginary part. Someone please tell me, what is mod Vs? What is mod Vs? What is the magnitude of the phasor voltage Vs? How do you find magnitude? Square the real part, square the imaginary part, add the two squares, take square root. Please tell me. Someone please tell me, what is the magnitude of this complex number? What is the magnitude of this complex number? 8 minus 6 cos 45 degrees is what the real part. 6 sin 45 degrees is what the imaginary part. What is its magnitude? Okay, the magnitude is what? 5.66. Okay. So mod Vs is what? 5.66. Remember, the magnitude of the phasor voltage is same as what? Amplitude. Yes, this magnitude is also same as what? The amplitude. So when you combine the two voltage components into one single term, for that single term the amplitude would be what? 5.66. Once you know the amplitude of that single voltage component, then the RMS or the effective value, would it not be amplitude divided by root 2? Yes. So V effective will be equal to what? 5.66 by root 2. What is 5.66 by root 2? 4. Okay. That's all. So for the B part, that is what for this entire voltage expression, which consists of what? Two voltage components. The overall RMS or the effective value is what? 4 volts. Okay. Is it clear? Because both are at the same frequency, you cannot say that for this first term the RMS value is what? 8 by root 2. For this component the RMS value is what? 6 by root 2. 8 by root 2 squared plus 6 by root 2 squared, and then I'll take square root and get the answer. That won't work in this case because both the components are at same frequency. Yes. So the answer would be 4. Okay. Let's go to C part. Let us go to C part. I think C part is straightforward because again the voltage consists of two components. Look at the first component. The first component, is it not at 200 radians per second frequency? Second component is what? 100 radians per second. So are we not having two voltage components at two different frequencies? In that case, these two voltage components are going to be orthogonal, in which case you can find the individual RMS values, square them, add them, then you take square root. Okay. So for the first term the RMS value would be what? 8 by root 2. For the second term the RMS value will be what? 4 by root 2. So for this V effective will be equal to what? Square root of 8 by root 2 squared plus 4 by root 2 squared. Someone please tell me the value of this. What's the value of this? Square root of 8 by root 2 squared plus 4 by root 2 squared. Is it 6.32? Very good. 6.32. So for the C part, the effective value of the voltage is what? 6.32 volts. Now we should also do it for the D part. Again the D part, look at the voltage expression. 8 sin 200t minus 6 cos again 200t minus some 45 degrees minus 5 sin 100t plus 4. Last term is what? DC. Yes, so this is what? DC. This is at a frequency of 100 radians per second, whereas the first two terms are at same frequency. So first you should do something and combine the first two terms into what? A single voltage component. Okay. Again I'll just do it on a new slide. So to start with, for 4 volt component, the RMS value is what? 4 volts itself, and for this component the RMS value is what? 5 by root 2 volts. Now you should combine the first two terms into what? A single component. Okay. Again, how do you go about it? Let us convert each of the two components into what? Their corresponding phasor representations. Okay. This time let us take cos as what? Reference. This time let us take cos as reference. Okay. If you take cos as reference, for this 6 cos 200t minus 45 degrees, what is the phasor representation? Is it not going to be 6 angle minus 45 degrees? So it is going to be 6 angle minus 45 degrees. Okay. What about the first term? 8 sine 200t. I told you what, if you are taking cosine as reference, first you write down amplitude followed by phase angle. 8 sine 200t, is it not 8 sine 200t plus 0 degrees? So first you write down 8 angle 0 degrees, because we are taking cosine as what reference, and this term is what, sine function. You add this minus j, that's all. So let's call it some capital V1. Let's call it some capital V1. So capital V1 will be equal to what? Minus j8. Remember, in between we also have this minus sign, right? Put that minus sign. Minus 6 at an angle minus 45 degrees. Okay. So now what I will do, I will split this 6 angle minus 45 degrees into a real part and an imaginary part. Okay. So real part is going to be minus 6 cos minus 45 degrees, and then minus j6 sine minus 45 degrees. Okay. Again, 6 cos minus 45 degrees, I think it is minus 6 cos 45 degrees, and then plus j times 6 sine 45 degrees minus 8. Understood? So the real part is what? Minus 6 cos 45 degrees, and the imaginary part is what? 6 sine 45 degrees minus 8. Again, I want the magnitude of this complex number. Please tell me, what is the magnitude of this complex number? Someone? Real part is what? Minus 6 cos 45 degrees. Imaginary part is what? 6 sine 45 degrees minus 8. Someone please tell me the magnitude of this complex number. Anybody else? Please tell me it's okay, 5.66. I'll go with 5.66. So what is mod V1? It is 5.66. Again, if mod V1 is what? 5.66. This 5.66 is obviously going to be what? The amplitude of the voltage component, which is at a frequency of 200 radians per second. So for this, the RMS value, would it not be 5.66 by root 2? That's all. Now we have the RMS values of all the 3 components. Okay, for this component, the RMS value is what? 5.66 by root 2. For this component, the RMS value is what? 5 by root 2. And for the last component, which is what? DC, the RMS value is also what? The same DC value, which is 4. Okay. So now that we have all the values, I think now we can find the overall RMS, or the overall effective value. So which is going to be what? Square root of 5.66 by root 2 whole square plus 5 by root 2 whole square plus 4 square. So in this way you will get the effective value. Someone please tell me the value of this. So here again we have a impedance Z, whose value is what? 16.26 at an angle 19.3 degrees ohms. Okay, 16.26 at an angle 19.3 degrees ohms. Okay. So what is the nature of the impedance? Is it inductive or capacitive? Tell me, what is the nature of this impedance? Inductive or capacitive? Please type in the chat box. Just by looking at the angle, of the impedance, you should be able to decide whether it is capacitive or inductive. Okay, please look at the screen, all of you. See, what is Z? What is the definition of impedance? Impedance is what? Phasor voltage, capital V, divided by the phasor current, capital I. Yes or no? Yes. So angle of Z. So think of this as a equation that has what? Complex numbers on both the sides. Okay. So Z is what? A complex number. V and I are also what? Complex numbers. Okay. Now every complex number will have a magnitude and also an angle. Yes. So angle of Z, will it not be equal to angle of V minus angle of I? Yes or no? Angle of Z will be equal to what? Angle of V minus angle of I. Now in our case, what is the impedance angle? What is angle of Z? 19.3 degrees. Yes or no? What is it? 19.3 degrees, and this is equal to what? The phase difference between voltage and current. So phase difference between voltage and current is what? Plus 19.3 degrees. So that means what? Voltage leads current. For which element voltage will lead current? Is it not for inductive, networks or inductive elements? Yes. So what is the nature of the impedance? It is inductive. Yes, nature of the impedance is what? Inductive. I hope it is clear. Okay. So Z is what? Inductive in nature. Z is what? Inductive in nature. Well, the other way to decide is what? See, Z is given in which form? Rectangular or polar form? Rectangular form is what? R plus Jx. R plus Jx. But here Z is what? Given in polar form. 16.26 at an angle 19.3 degrees. How do you get it in the rectangular form? Is it not by writing it as 16.26 cos 19.3 degrees plus J into 16.26 sine 19.3 degrees. 16.26 into sine 19.3 degrees. Is it not positive? That means what? Reactance is positive. For which element? For which reactive element the reactance is positive? For which reactive element the reactance is positive? Inductor. Yes or no? For inductor, the reactance is what? Positive. What is the reactance of inductor? XL, omega L. Is it not positive? What is the reactance of capacitor? Minus 1 by omega C. Is it not negative? Yes or no? Capacitive reactance is what? Negative. Inductive reactance is what? Positive. Yes. Even from this, if you expand this into what? That real plus J times imaginary, you will find that imaginary part of the impedance is what? Positive. That means what? Reactance is positive. Only for inductor, the reactance is what? Positive. In that way also we can say the nature of the impedance is going to be inductive. Nature of the impedance is what? Inductive. Okay. In fact, we can take this discussion a little forward. What are the three possibilities? What are the three, not three, any impedance, These are the four possibilities. Okay, for any impedance can be what? Purely resistive. Purely resistive, it means what? There is only resistor, there is no capacitor, there is no inductor. It is what? Purely resistive. Any impedance can also be purely reactive. That means what? There are no resistors in the network or in the branch. You only have reactive elements. It can be capacitor or inductor or some combination of or some connection of capacitors and inductors. It is what? Purely reactive. Or it can be having, impedance can be what? Having an overall inductive nature or an overall capacitive nature. Okay. Overall inductive nature, it means what? It has both a resistive part and also a reactive part, which is what? Inductive. Overall capacitive nature, it means what? It has a resistive part and also a reactive part which is what? Capacitive, okay? But purely reactive, it can be what? Just the inductor, or it can just be the capacitor. You understood? Yes. Now for purely resistive, what is the impedance angle? By the way, this impedance angle, that is what? Angle of Z. Is it not theta minus phi? Angle of voltage is what? Theta. Angle of current is what? Phi. Angle of voltage minus angle of current is what? Theta minus phi. So in fact, the angle of the impedance is same as what? Theta minus phi. Phase difference between voltage and current is nothing but the impedance angle, because impedance is what? After all, phasor voltage divided by phasor current. Now for purely resistive, theta minus phi, is it not 0? Because voltage and current will be in phase. So angle of Z is equal to what? 0 degrees. Now within purely reactive we have two cases. It can be a pure inductor or it can be a pure capacitor. For pure inductor, what is the impedance angle? Pure inductor, voltage leads current by 90 degrees. That means what? Angle of voltage minus angle of current is what? Plus 90 degrees. So for purely inductive impedances, the impedance angle will be what? 90 degrees. You understood? Now the other purely reactive impedance is what? The capacitive thing, where the entire impedance can be represented by just a single capacitor. Again, for a capacitor, what is the impedance angle going to be? Is it not minus 90 degrees? Because for a capacitor, current leads voltage by 90 degrees. Current leads voltage by 90 degrees. Angle of current minus angle of voltage is what? 90. But our impedance angle is what? Phase difference between voltage and current, which is going to be minus 90 degrees. So for a pure capacitive impedance, the impedance angle is going to be minus 90 degrees. The impedance angle is going to be minus 90 degrees. Now when it comes to overall inductive nature for the impedance, overall inductive nature, it means what? There will be some resistive part, there will also be some inductive part. Because it is what? Inductive, always when the impedance is what? Having an inductive nature, voltage will lead current. Voltage will lead current. In fact, the impedance angle will lie in the range 0 degrees to plus 90 degrees. If it is purely inductive, it would be plus 90 degrees. If it is purely resistive, it would be 0 degrees. But it is somewhere in between purely resistive and purely inductive. So the angle of the impedance would also lie in between 0 and 90. I hope it makes sense. Okay. What is the last case? You can have an impedance which has some resistance, which also has some capacitance, but the overall nature is said to be capacitive. Overall nature capacitive, it means what? Voltage will lag current. Voltage will lag current. So the phase difference between voltage and current is going to be negative. So at one extreme, it can be purely resistive, in which case the angle of the impedance would be 0 degrees. At the other extreme, the capacitive impedance can be purely capacitive, in which case the angle of impedance can be minus 90 degrees. So what is the range of the impedance angle in this case? Will it not lie between 0 degrees and minus 90 degrees? Yes, 0 degrees and minus, that's all. These are the different possibilities for the impedance angle. Always remember, impedance angle is what? The phase difference between the voltage and the current, which is denoted by theta minus phi. So from this diagram or whatever, can you tell me what is the range of possible values for angle of impedance? Please type in the chat box. What is the range of values possible for the angle of any impedance? What is the range of possible values of angle of impedance? What is the most negative value possible? Minus 90 degrees. When it is purely capacitive. Yes. What is the most positive value possible? Plus 90 degrees when it is purely inductive. Yes. So always the angle of impedance lies in the range minus 90 to plus 90. Okay. That is the bottom line of this entire discussion. Angle of Z, it always lies between minus 90 to plus 90 degrees. I mean minus 90 degrees to plus 90 degrees. Minus 90 degrees when it is purely capacitive, plus 90 degrees when it is purely inductive, 0 degrees when it is purely resistive. You understood? Yes. Anyway, come back to this one. So we have an impedance which is given in polar form as what, 16.26 at an angle 19.3 degrees. And the phasor voltage is also given. Given the phasor voltage and the impedance, you should find two things. First is what? The instantaneous power absorbed by the impedance Z. Instantaneous power absorbed by the impedance Z. Second is what? Average power absorbed by Z. I think finding average power is very straightforward, because see, first we will answer the B part, then we will go to A part. Okay. Instantaneous power, that means what? Power as a function of time. Instantaneous power, it means what? Power absorbed by this impedance as a function of time. What is also given? The frequency of the voltage is given 50 radians per second. That means omega is what? 50 radians per second. Okay. Anyway, first we will try to answer the B part, which is to find the average power absorbed by the impedance. Okay. So given the phasor voltage and the impedance itself, can't we find the phasor current flowing through the impedance denoted by capital I, which should be equal to what? V by Z. So what is V? 115 root 2 at an angle 45 degrees divided by 16.26 at an angle 19.3 degrees. Someone please tell me what is 115 root 2 divided by 16.26, and also you tell me the angle. Angle is very straightforward. You just have to take the difference between the numerator angle and the denominator angle. What is the magnitude of the phasor current I? 10 at an angle 25.7. Okay, very good. So the phasor current is what? 10 at an angle 25.7 degrees, units amperes. Okay, that's all. You see, what is the expression for the average power absorbed by any impedance? The general expression is what? V effective into I effective into cos of theta minus phi. Remember, theta is what? The phase angle of the voltage. Phi is what? The phase angle of the current. Yes. What is the phasor voltage? 115 root 2 at an angle 45 degrees volts. Here it is not mentioned volts RMS. If I write it as volts RMS, then this 115 root 2 is going to be what? The RMS value, the voltage. But here that RMS is not mentioned. That means you can take this 115 root 2 as what? Amplitude. If 115 root 2 is what? Amplitude of voltage, what would the RMS or the effective value of voltage be? Amplitude divided by root 2. Yes. Look at this. 115 root 2 by root 2 times I effective. Once again, the phasor current is what? 10 at an angle 25.7 degrees. Again, it is not amperes RMS. So this 10 amperes can be taken as what? This thing, amplitude. So what is the effective value going to be? Will it not be 10 divided by root 2? It will be what? 10 divided by root 2. And then cos of theta minus phi. Theta is what? The phase of the voltage. What is the phase of the voltage? 45 degrees. In fact, theta minus phi is what? The impedance angle. Yes or no? Theta minus phi is what? The impedance angle, which is 19.3 degrees. Okay. Angle of impedance is what? So someone please tell me the value of this. Somebody please tell me the value of this. So now, is it clear? I hope everybody got the same value, 767.47 watts. Okay. Okay, now let us try to answer the A part, which is to find the instantaneous power absorbed by the impedance Z if the frequency of operation is what? 50 radians per second. So don't we already know the for voltage and the current both in phasor domain? Yes. So what is the voltage? So now we are answering the B part. What is the voltage given as? I think 115 root 2, correct, right? Voltage is what given as 115 root 2 at an angle 45 degrees volts. And then from the impedance we found the current, and the current came out as 10 at an angle 25.7 degrees. So I is what 10 at an angle 25.7 degrees amperes. Okay. Now V of t can be written as what? 115 root 2 cos of omega t, which is 50t, cos of 50t plus 45 degrees volts. Similarly, I of t can be written as what? 10 cos the same omega t, which is 50t plus 25.7 degrees amperes. That's all. So now the power absorbed as a function of time. Power absorbed as a function of time. I think the first term is what? The average value of the power absorbed, right? Already we found the average value of the power absorbed, which is 767.47. Okay. It would be V effective, I effective cos of theta minus phi plus Vm Im by 2 cos of 2 omega t plus theta plus phi. Now let us just substitute the different values into this expression. Already V effective, I effective cos of theta minus phi is what? The average power absorbed, which is 767.47. Okay. 767.47. And then Vm Im by 2. What is Vm Im by 2? 115 root 2 into 10 divided by 2. 10 by 2 is what? 5. 5 times 5 is what? 25. 5 root 2. And then I'm getting this 575 root 2. 575 root 2 times cos of 2 omega. Omega is what? 50. 2 omega is what? 100. 100t plus theta plus phi. Theta is what? The angle of the voltage, 45. Phi is what? The angle of the current, 25.7. Theta plus phi would be 45 plus 25.7. 45 plus 25 is what? 70.7 degrees. Okay. Units watts. That's all. This is the power absorbed by that impedance as a function of time. The first term is what? Constant, independent of time, which is going to be the average power absorbed by the impedance. So this already we know it is what? P average. And this is what? The sinusoidally varying part, and you can see the frequency is what? 100 radians per second, twice the frequency of the voltage and also the current. Okay. Is that correct? Did anyone write the same expression? Yes. Let's take up one more simple example. So again we have an impedance through which the current is what? I. The impedance value is what? 6 at an angle 25 degrees ohms, and the phasor current flowing through the impedance is what? 2 plus J5 amperes. 2 plus J5 amperes. You have to find the average power absorbed by the impedance, absorbed by Z. Just quickly type your answer in the chat box. It's very simple. So the impedance value is given, the phasor current is also given. What is this thing? Average power absorbed by Z. Okay, all of you please look at the screen. You can do it in multiple ways. First of all, the impedance is what given in polar form. You can convert that polar form into what rectangular form so that you will get the resistive part of the impedance. Why is the resistive part of the impedance important? Because it is only the resistive part of the impedance that will contribute to what average power absorption or dissipation. Okay, and the current is given in rectangular form. Current is what given in rectangular form. Look at this. So the formula that I will try to use is what this. So P average is what? I effective squared into R. I effective squared into R. Okay. So here you should find both the values of I effective as well as R. So how do you get R? So Z is what? 6 angle 25 degrees ohms. So from here R is what? Is it not the real part of Z? Real part of Z is what? 6 cos 25 degrees. Someone please tell me the value of R. And also the phasor current is not given in polar form, it is given in rectangular form. Okay, 2 plus J5. 2 plus J5. What is 2 plus J5 in polar form? 2 plus J5 in polar form is going to be square root of 2 square plus 5 square, which is 29 at some angle phi. At some angle phi. Angle is not important. Okay. So what is this root 29? Is it not the amplitude of the current through this impedance? Once you know amplitude, can't we find the effective value? Effective value is always going to be the amplitude divided by root 2. That's all. Please tell me 6 cos 25 is how much? What is 6 cos 25? Is it 5.43? Yes, 5.43. Okay. So the resistive or the real part of the impedance is what? 5.43 ohms. That's all. Once you know resistor, can't we find the average power absorbed by the impedance using the formula I effective squared into R. I effective is what? Root 29 by root 2. When you square it, you will get 29 by 2 into 5.43. Someone please tell me the value of this. 29 by 2 times 5.43. Okay, 78.58. This must be correct. I hope the method is clear. Okay. 78.58 watts. That is the average power absorbed by this impedance. Okay. Well, the other way to do it is what? Given the impedance and given the current, when you multiply the impedance and the current, won't you get the phasor voltage? Once you get the phasor voltage, then again you can find the average power by using the formula V effective into I effective into cosine of theta minus phi. Already theta minus phi is what? The same as impedance angle, which is 25 degrees. So V effective into I effective into cos of 25 degrees also will give you what? The same answer. Okay. Let's take up one more example. I think this is very straightforward, right? Because the current is directly given in polar form. So I is what? 5 at an angle 20 degrees. So what is the effective value of the current? Is it not 5 by root 2 amperes? Yes. And what is the value of the R? R is what? Just the real part, which is 8 ohms. So once you know I effective and also the value of R, the average power dissipated by the impedance will be equal to what? I effective squared into R, which is 5 by root 2 whole squared into 8. Root 2 squared is what? 2. 8 by 2 is what? 4. 4 times 25 is what? 100. I hope all of you got 100 watts. Yes. Okay, there is some network being driven by two sinusoidal voltage sources. Okay, the one on the left its phasor voltage is what 20 at an angle 0 degrees volts, and the one on the right, its phasor voltage is what 10 at an angle 0 degrees volts. There is 20 at an angle 0, there is what 10 at an angle 0, and we also have three other passive elements: inductor whose impedance is what J2, capacitor whose impedance is what minus J2, and also this resistor whose value is what 2 ohms. The question is what to find the powers absorbed by all the elements, meaning, in fact I should have written find average powers absorbed by all the elements. That means what is the average power absorbed by this source, what is the average power absorbed by this source, what is the average power absorbed by the 2 ohm resistor, what is the average power absorbed by the inductor, and also what is the average power absorbed by the capacitor. Okay, amplitude, voltage, the 20 volts is what amplitude. You can take 20 volts is what amplitude. If it is RMS, I would definitely write it as 20 angle 0 degrees volts RMS. So this 20 volts is what amplitude, 10 volts is also what amplitude. In fact, for the two reactive elements, that is what for the inductor and also for the capacitor, directly we can say the average power absorbed is what 0, because reactive elements do not absorb any average power. So for the two reactive elements, the inductor and the capacitor, directly the average power absorbed would be 0, but for the resistor it is not 0. And how do you find that? By doing analysis and finding either the voltage across the resistor or the current flowing through the resistor. So now what I am going to do, I will perform simple nodal analysis. I will perform what? Simple nodal analysis. Look at this. So this is the circuit. Nodal analysis, that means what? We write KCL at various nodes. The first step in nodal analysis is to choose one of the nodes to be ground. For convenience, let us choose, for convenience, let us choose this node to be ground. Once you choose this node to be ground, what is the voltage at this point? 20 volts. What is the voltage at this point? It will be 10 volts. Let us assume the voltage at this point to be some Vx. Let's assume the voltage at this point to be some Vx. Now what is this current? 20 minus Vx by J2. What is this current? 10 minus Vx by minus J2. What is this current? Vx minus 0 by 2. So clearly at this node, this current and this current both are entering, this current is what leaving. So what is KCL at this node going to be? 20 minus Vx by J2 plus 10 minus Vx by minus J2 is equal to what? Vx by 2 is equal to what? Vx by 2. I think 2 is what common throughout. 2 will get cancelled. Remember 1 by j is what? Minus j. 1 by j is what? Minus j. So 20 by j will be what? Minus 20j. Again 1 by j is what? Minus j. So minus 1 by j will be what? Plus j. So plus j times Vx. Again 10 by minus j would be j10. Yes, plus j10. Again minus and minus will get cancelled. 1 by j again is what? Minus j. So minus j Vx is equal to what? Vx. That's all. I think here this jVx and minus jVx are getting cancelled. I hope this is correct. So on the right hand side Vx is left. On the left hand side minus 20j plus j10. Minus 20j plus j10. So Vx, is it not simply minus 10j units volts? Vx is what? Minus 10j volts. Is it correct or not? Is it correct? This node voltage is what? Minus 10j volts. Minus 10j volts. See, what is this Vx? I mean, if it is minus 10j, is it not 10 at an angle minus 90 degrees volts? Yes or no? Vx is what? Minus j10. It is same as what? 10 at an angle minus 90 degrees volts. Now across the 2 ohm resistor, what is the drop? Is it not Vx? If you look at this circuit, the drop across 2 ohms is what? With this polarity Vx minus 0. This is what? Ground. Vx minus 0 is what? Vx. And what is Vx? It is 10 at an angle minus 90 degrees volts. So what is the amplitude of the voltage across the 2 ohm resistor? 10 volts. What is the RMS value? 10 by root 2. Yes, I think now we can write down the average power absorbed by the 2 ohm resistor. It would be 10 by root 2 squared into 1 by R. 10 by root 2 whole squared is what? 100 by 2. R is also what? 2. 100 by 2 into 2. 100 by 4 is what? 25. So R, remember, is what? 2. So the average power absorbed by the 2 ohm resistor is what? 25 watts. Okay. Let us call this current as what? I1. Let's call this current as what? I2. Okay. Now if that is I1, this is also what? I1. And if this is what? I2, this is also going to be I2. So to find the power absorbed by this source, you should multiply the voltage with the current. Okay. Power absorbed by any element is what? Voltage times current flowing into plus. So here if you look at the direction of I1, I1 is it flowing into plus or out of plus? I1 flowing out of plus. In fact, if you multiply voltage with this I1, you will get the power supplied. But if you want the power absorbed, you should multiply voltage with minus I1. You should multiply the voltage with minus I1. Anyway, let us try to find I1. How do you find I1? I1 is what? 20 minus Vx by J2. Okay. So I1 is what? What is I1? 20 minus Vx. I think we can do it here itself. I1 is what? 20 minus Vx by J2. 20 minus what is our Vx? Minus 10J. 20 minus of minus 10J is what? 20 plus 10J divided by 2. Correct, right? 20 by 2 is what? 10. 10J by 2 is what? 5J. This is I1. This is what? I1. Okay. 10 plus 5J. In the same way, we can also find I2. What is I2? I2 is what? 10 minus Vx by minus J2. 10 minus Vx by minus J2. Again, Vx is what? Minus 10J. So 10 minus Vx would be 10 plus 10J. Correct, right? I think here I missed J. Sorry. 20 plus impedance is what? J2, right? Impedance is what? J2. Okay, 10J by 2J. J and J will get cancelled. 10 by 2 is what? 5. And 20 by J2 is what? 10 by J, which is 5 minus 10J. Okay, I am getting this. I1 is what? 5 minus 10J. I1 is what? 5 minus 10J. Okay. In the same way, I2 is what? This current. 10 minus Vx by minus J2. 10 minus Vx. Again, Vx is what? Minus 10J. So will it not be 10 plus 10J divided by minus J2? Again, 10J by minus J2. J and J will get cancelled. 10 by minus 2 is what? Minus 5. So minus 5 plus 10 by minus J2. 10 by 1 by minus J is what? I think plus J. 1 by J is what? Minus J. Minus and minus will get cancelled. So is it not minus 5 plus 5J? It must be correct. minus 5 plus 5J amperes. These are the values of, these are the two phasor currents I1 and I2, okay. I1 is what, 5 minus 10J, I2 is what, minus 5 plus 5J, okay. So again, I have drawn the original circuit. Let me just write I1 and I2. Yes. First of all, the direction of I1 is what, like this, okay. I2 is what, like this. So here, this current is what, I1. This current is what, I2. Okay. And what did we get for I1? What did we get for I1? Look at this. I1 is what, 5 minus 10J. I1 is what, 5 minus 10J amperes, okay. And let us call this phasor voltage as what, V1, and this phasor voltage, let's call it V2. So what is V1? 20 at an angle 0 degrees. What is V2? What is V2? 10 at an angle 0 degrees, okay. You see, minus I1, what is it? Minus I1. I1 is what? 5 minus 10J. Minus I1, will it not be minus 5 plus 10J amperes? Why am I interested in minus I1? Because I1 is what, flowing out of plus. Yes, but we want the average power absorbed by the source. Average power absorbed by the source will be related to what? Voltage times current flowing into plus. I1 flowing out of plus, whereas I1 minus I1 will flow out into plus. That's why. Or else you can simply compute the power supplied and then negative of it will be what? Power absorbed. That is also one way to do it, okay. Anyway, here I am just directly finding the power absorbed, for which I should multiply voltage with the current flowing into plus. I1 is what? Flowing out of plus. Current flowing into plus is going to be what? Minus I1, okay. I want you to tell me this minus I1, which is what? Minus 5 plus 10J in polar form. Tell me this minus 5 plus 10J in polar form. Are you sure about the angle? Minus 5 plus 10J, would it not lie in third quadrant? Minus 5 plus 10J will lie in what? Third quadrant. So the angle should be minus 5 plus 10J. Second quadrant, sorry. Minus 5 plus 10J would lie in what? Second quadrant. And in the second quadrant, the angle should lie between 90 and 180. So whatever angle you are saying, 116.56, that must be correct. And the magnitude is what? 11.18, okay. So it's minus I1. So it's minus I1, it is like, it is how much? 11.18. 11.18 at an angle 116.56 degrees, amperes. Now look at this. We have a voltage source. Whose value is what? 20 at an angle 0 degrees volts. And what is this current? Current flowing into plus terminal is what? Minus I1, which is 11.18 at an angle, 116.56 degrees amperes. Now I am not having a two-terminal element across which we know the voltage, phasor voltage, and also the phasor current flowing into the plus terminal. That's all. So here directly we can find the average power absorbed by this first voltage source on the left side by using the formula V effective into I effective into I effective times cos of theta minus phi. What is V effective? 20 volts is what? The amplitude. So will it not be 20 by root 2 into I effective? Again 11.18 is what? The amplitude. of the current, RMS value will be 11.18 divided by root 2 into cos of theta minus phi. Theta minus phi. Theta is what? Angle of voltage, which is 0 degrees. Phi is what? The angle of the current, which is 116.56 degrees. So what is theta minus phi? Cos of minus 116.56 degrees. Please tell me the value of this. 20 by root 2 into 11.18 by root 2 times cos of minus 116.56 degrees. Someone please tell me the value of this. This will be the average power absorbed by this voltage source, whose phasor voltage is what? 20 at an angle 0 degrees. Well, I am sure it is negative, right? It is negative because cos minus 116.56 degrees, it will be negative. So we will take it as minus 50, minus 49.989, we will take it as what? Minus 50, okay? So minus 50 watts. This is the average power absorbed by this source. Average power absorbed by this source is what? Minus 50 watts. What is the average power supplied by this source? Plus 50. So in this circuit, this source is actually what? Supplying power. This source supplies power. How much power? It will supply an average power of plus 50 watts. Supplying an average power of plus 50 is same as what? Absorbing an average power of minus 50. In the same way, we will also do it for this case, okay? In fact, directly we can say, okay? See, look at the screen, all of you. What is the average power absorbed by the inductor? 0. Reactive element, average power absorbed is what? 0. Average power absorbed by inductor is what? 0. Average power absorbed by capacitor is also what? 0. Previously we found that the average power absorbed by the 2 ohm resistor is what? 25 watts. And now we found that this source is what? Supplying 50. Look at this. This source is supplying 50. Resistor is what? Absorbing 25. So what will the other source do? Please type in the chat box. What will the other source do? This source is what? Supplying 50, out of which resistor will absorb 25. What will this source do? Will it supply or absorb? Absorb. Absorb how much? Why 75? 25, no? 25. Because already one source is what? Delivering 50, out of which 25 is getting absorbed. The remaining 25 will be absorbed by the other source, okay? So here, you know the 10 at an angle 0 degrees volts, this is going to what? Absorb, not 50, I'm sorry, absorb 25 watts. You understood? That's all. So the final conclusion is what? This one, it supplies 50 watts. This will absorb 0 watts. This will absorb 0 watts. And the resistor will always absorb, right? And it will absorb what? 25. And the other source also absorbs 25 watts. Again, energy is what? Conserved. Whatever energy is being supplied by this, that is getting absorbed, or whatever power is supplied by this, that is getting absorbed by both the resistor and the other source, okay? So this one supplies 50, out of which 25 will go to the resistor, the remaining 25 will be absorbed by the other source. Is that clear? So this is an introduction to power calculations in AC circuits, okay? We will take up one more small session on this same topic.